Good evening and welcome to our session where we're going to be talking about the future of structural design. Really looking forward to this session. Before we dive into the content, just a reminder, we would love this session to be as interactive as possible. We'd love to know what you think. We'd like to know what your questions are. So if you have a question, if you could share it as it comes into your head as we're talking, that would be amazing. So click on the chat function, go up to the little Q&A bubble, click on that, and then your question will pop into there. If you are looking at the questions and you spot someone else has already asked it, you can uprate questions as well. So if there are loads of questions, you can help us find the right ones. So I'm going to be your host for this evening. My name is James Norman, and I'm a professor of sustainable design at the University of Bristol. And this evening, we're joined by Alex, Flavia and Raffaele, all from the University of Bristol. We're all colleagues together. And we're going to be talking about different aspects of the future of structural design. So Alex is going to be talking about ethics. Flavia is going to be talking about reuse of existing buildings. Raffaele is going to be talking about probabilistic approaches. And then I'll be talking about what the future of structural design could look like. And this is a book launch. So there is a book attached to this. And we are just 4 of the 9 authors. So also involved in the book is Scott, Dan, Philip, Dan and Gavin from the University of Bath. That's Dan and Gavin. And then also 3 people from industry. So this is not just academics thinking about what design could look like. It's also people in industry thinking about what design could look like. And actually, some of us who are academics have also been designers in previous lives. So we're really excited to talk to you about this subject. We really would love to know your thoughts, and I encourage you to join in the conversation. Just a quick reminder about copyright. To the institution's best knowledge, copyright permission has been provided for all materials shown, and this broadcast is therefore presented in all good faith. If the copyright holder believes permissions have not been forthcoming, then the relevant item will be removed, or by agreement, an appropriate acknowledgement provided to accompany the e-lecture. So with no further ado, now you know where you stand in terms of copyright. I would love to hand over to Alex, who is going to start us off by thinking about ethics, because as structural engineers, we are making big decisions. We're involved in huge projects and they have a very large ethical dimension. So I'm going to hand over to Alex, who is going to talk to us about ethics in this space.
Thank you, James, and hi, everyone. I am Alex Dietzel, as James said, and I'm not an engineer. I'm, in fact, a climate justice scholar and a social scientist. And a few years ago now, James was telling me about this book and asked me whether I could write a chapter concerning the ethics of structural design, and was super supportive about it. And in the end, we ended up co-authoring the chapter, and it's gone through lots of different drafts, which has been interesting. And it's my pleasure now to kind of introduce why we wrote this ethics chapter and how the book can help you to think about ethics as well. So the first question to kind of ask when writing the chapter was, why should engineers, and in particular structural engineers, think about ethics, and why was ethics a kind of key part of the book? So obviously, to someone like me who thinks about this all the time, the climate and biodiversity emergency contain essential ethical questions. And that is what my work and the work of people like me is all about. And those kinds of questions include, who should have how much responsibility, who should be making decisions about climate change, who needs to pay for things like loss and damage, etc. So for me, the ethical dimensions of climate change and biodiversity are kind of my bread and butter. But when thinking about why it might matter for engineers, what's important to note is that in my work, I argue that what I call non-state actors, so people like cities, organizations, or even individual people, are really important in ethical questions around climate change, because their efforts to mitigate climate change, adapt to its impact, and aid those who will suffer from it plays a kind of key role to the response to climate change. And because of that, they're really important, including engineers. And most importantly, really, these actors can create conditions for systemic change. So that means they can change the way we do things within industries, within sectors, or within cultures or ways of doing things. So really, the chapter is kind of trying to stress that your role as a structural engineer or someone working on a project, even if it's a small role, can be quite significant in terms of the kind of ethical impacts that you can have. And so what we explain in the chapter is that engineers and their institutions are agents of climate justice, really important agents of climate justice, particularly those who make design decisions and who might be able to make a difference between a city achieving climate goals or even a country meeting or not meeting their nationally determined contributions under the Paris Agreement. So essentially, what I'm trying to tell you is that engineers are very important people. So I hope that's good news that you're hearing that, and that you can really play a role, especially when thinking about the ethics of design. And so the book kind of opens with an overview of this, of your role. But more importantly, we also give some initial tools to help kind of grapple with ethical questions of design. And we hope that the chapter will actually be kind of a springboard or a starting point to enable engineers to navigate ethical questions. And those mainly concern climate change justice, but also broader questions about how conventional code approaches and takes account of the cost of human life. So the kinds of things we talk about in the chapter are the role of people who live in wealthier countries. So maybe there's more responsibility in our hands, for example, weighing up things like the local and the global impacts of design. So thinking, of course, about climate change or sustainability locally when making design decisions, but also comparing those to the global impact of a high emissions project. So the impact on climate change or environmental impacts more broadly. And also questions of acceptable risk of failure versus climate impacts. So when the risk of failure has to be at a certain level, that means certain materials might have to be used. There might be constraints with the project, but that can impact the lives of those who live in other places, or it can impact climate impacts more broadly. And of course, we also talk about reusing existing buildings and why that might be important to reuse existing materials when thinking about climate ethics and environmental impacts. And in order to help with that, I cover two specific tools. So one is kind of principles that you can think about when you're considering responsibility, including your own personal responsibility or the responsibility of the project as a whole. So for example, I talk about things like the ability to pay and polluter pays, which are philosophical principles to ponder the kind of responsibility that you hold. So how much wealth do you have as an agent or as a company? How much pollution have you produced in the past? Things like that. And then perhaps even more interestingly, what to do if you're an ethical agent, but you're in an unjust system. So maybe you have very strong ethical opinions or you have a strong kind of moral compass, but you're in this wider unjust system. What can you do? And I introduced one of my favorite scholars, Iris Marion-Young, to help you think through that question. And on a final point, I just want to say that the main aim of the chapter is not to try and arouse guilt or shame or to make engineers throw up their hands and give up in the face of, a sense of futility or being a tiny part of a much bigger scheme of injustice. In fact, we want the opposite. We really want engineers to feel empowered to try to consider decisions around risk and climate change more nuancedly, even if it is harder than continuing to act as you usually would. So whenever I take, this subject matter to an audience, whether that be students or the public or tonight engineers, I always want you to understand that ethics can help you to make things slightly better and shouldn't, make you kind of turn inwardly towards guilt and shame, because that's a distraction. We're part of a bigger system. We have a role to play, and we should use the momentum that we have as individual agents of justice. So that's the kind of main message of this chapter. And now, thank you for listening to me. I will hand over to Raffaele.
Thank you very much, Alex, for your introduction. And Okay, so it is a pleasure today being here and presenting this 3 years effort. In particular, I'm going to provide you some of the information that we are presenting in the book related to uncertainty and risk in structural engineering. I am an associate professor in civil engineering, and it's almost 10 years that we are trying to embed these concepts in our curriculum. Interpreting probability in structural safety is often perceived as a rather a philosophical conundrum. However, nowadays we have tools, we have methodologies that are a unifying framework for managing uncertainties affecting structural performance and allow a quantitative risk, a quantitative link between structural engineering and structural engineering practice with the counterpart social consequences. Let me provide you a little bit more about this. So we are not an industry of mass production. So we create some one-of-a-kind structures and infrastructures, and these are affected by stressors. So let's think about wind loading, gravitational loads that may be very variable. There are many aspects that may lead to a lot of uncertainties. And at the same time, we try to provide the structure with the capacity, with strength that is itself very affected by uncertainties. So we need to embrace uncertainties, and we need to try to propagate them to the final result. In addition to that, the design should also be associated with risk, where for risk, we define the frequency or probability, if you want, of a failure, so what can go wrong, and the associated consequences. So what we think is that in the future, we expect that practitioners and professional engineers will be able to propagate and consider all the uncertainties and then address reliability and risk explicitly. So not just with the approach that we use nowadays, but explicitly providing the results in a very clear manner. And this is what we think it should be the next generation of building codes in a period where several Eurocodes are going to be updated, and in a period where computational power and a lot of tools are available, and so all these methodologies can be easily implemented. But what was the idea that is behind the preparation of this book and the set of questions that we try to answer that has ruled the preparation process of the book itself? Well, as always, we tend to work on and to build upon the shoulder of our ancestors, and we create models as engineers. These may be mathematical models, these can be structural models, these can be probabilistic models. And we know that all models are wrong, but some of them are useful, or that certainty is something that is an unpleasant condition, but certainty is absurd. So building upon this background, in preparing this book, we started to consider what are the possible aspects that we should have discussed and what we have discussed in the book. In particular, we discussed the treatment of uncertainties in structural engineering. We provided a theoretical and practical introduction to structural reliability methods, moving from the classical one up to the more modern simulation-based approach. Then we provided a practical implementation of these reliability-based approaches. Then we shifted our interest to theoretical and practical implementation of risk-based design. So this is a very important shift from simple reliability to risk. And when you do that, you need to discuss about ethical issues, and Alex has presented our thoughts on that. And you need at some point to come up with some level of risk acceptability, which is a very difficult task. Across the book, we will also find some examples on what we think is reliability-based and risk-based design. Now, once we have organized the book, we also asked ourselves, but is what we are providing here different from current practice? Is this something new? Well, you will see in the book that there is a chapter about the history of structural reliability, and this is a very, I would say, well-consolidated topic in the literature. And the methodology that structural designers use every day is identified as level 1, or semi-probabilistic approach, where we use the so-called partial safety factors. However, no one stops us to introduce the probability distributions more explicitly, either just by mean standard deviation or the entire shape of the distribution, moving to level 2 and level 3. And as soon as we introduce consequences, then we move to level 4, which is risk-based design. Some of these approaches are also coded for you, and codes are made available on online platform, repository platform. In studying all these aspects, we could not avoid to discuss about important aspects such as structural analysis, material properties, and physical testing, each one deserving a specific chapter. Structural analysis, it is very well known that when we create structural models, there may be a lot of uncertainties, for example, about boundary conditions. Sometimes we have pure fixity, or there is the need for introducing some elastic deformability. So these are all things that must be accounted in our model, and let me say model uncertainty. It is indeed clear that as soon as we have uncertainties, we need to these are not related only to the stressors, so gravity load, wind, earthquakes, snow loading, but it's also related to materials. Materials are also a huge part of the epistemic uncertainties that we deal with. And therefore, we provided some details on how to characterize the uncertainties for material properties. And one of the key components to acquire data for material properties is certainly physical testing. Physical testing is treated in this book in a specific chapter, providing not only the way for acquiring new data and reducing epistemic uncertainty, but also it is used as a way for design. And we acknowledge that testing is becoming more prevalent with the advent of regenerative design and place-based design. And certainly we move to risk-based design now. So we need to be able to define what risk-based design is. And we also try to develop some procedure that are the starting point for opening the discussion about this very topic. So when we talk about risk-based design, we need to consider the socially acceptable risk level. So we have alternatives, we have different options. We investigate these options with conventional approaches, but then we need to come up with the assessment of the risk associated with different alternatives. And at some point, we need to come up with a comparison between the calculated risk and the acceptable risk levels. However, acceptable risk levels cannot be defined by us. They have a very huge political dimension. Alex has introduced this to you earlier. And we started the discussion about the comparison of this risk level with the risk levels that are more clear to us, such as, for example, the risk associated with a car accident or loss of life due to smoke, for example. These are all numbers and order of magnitude that we should have very clear in mind. So we identified a risk cyclicity where we start with the risk goal identification. We compute the risk, so we explain how to convolute exposure, hazard, and vulnerability. We compare risk goal and risk assessment in order to appraise the level of risk with the risk appraisal step, and then after that we come up with a decision that depends on the different alternatives that we have. And this is not stopping here, because then we have monitoring and review. This thing should be constantly monitored because we are moving from the risk of a new build to the risk of existing structures. And this entire procedure should constantly be communicated and should be constantly discussed with stakeholders and owners. So this is what we think and what we have presented. We have also presented some examples across the book, as I mentioned earlier. In particular, we studied a rammed earth building, and we have discussed both the one of these walls and a joist. So very simple examples. This is not an how-to, but is rather a starting point to discuss about these very topics. And with these very simple examples, we can already provide you with, for example, loss curves, which are curves providing the relationship between the loss and the probability of exceedance of that loss. And this loss can be both economic in terms of financial terms, so pounds, or it can be in terms of sustainability, so CO2 emissions. These are heterogeneous quantities that can also be combined. Obviously, the combination of heterogeneous quantities is out of scope of this book. And when we have the losses, we need to be able to compare them with some limits, and the definition of these limits can borrow the approach adopted for the ALARP region, as low as reasonably possible, where we may have acceptable, unacceptable, or acceptable with extra expenses areas. So in definition, basically in the defining all these aspects, so now we can tell you why this book can help and how this book can help. Well, this book is a book that comes almost 2 decades after the compilation of the very first probabilistic structural model code. It may provide you with some flavor and some idea on how the future may look like. apart from the methodologies and the technique that we have discussed in the book and the different chapters and the appendices of the book that are keep evolving, so they are by no means exhaustive, there is the need for a broader discussion on the what risk-based is, what the risk limits are, and how they should be defined. So we really hope that this book will help in the first step towards the future, and will inform your opinion on what the future of structural engineering is and what comes next. So thank you very much for your attention, and I now leave the floor to Flavia.
Hello. I am sharing my slide. Okay. So thanks, Raffaele, for the introduction. I am Flavia De Luca, Professor of Structural and Earthquake Engineering at the University of Bristol. Today, I'm going to cover the part of the book about reuse of buildings and bits of buildings. This is the part of the book that I have been going through with Gavin. And as Alex, James, and Raffaele have been saying, this book has been a long journey. And within this journey about the future of structural design, we could not avoid to talk about how we reuse buildings and how this risk-based approach, this kind of future of design affects also how we deal with existing buildings. So first of all, there is the very question of how many lives do buildings have? So all buildings have multiple lives. All buildings need maintenance. Some might get more than just this. Some of them get are refurbished and go well beyond their original use. And the thing is that one building reused saves a new building being built. The thing is that as structural engineers, we can work with existing buildings in different ways. We could work with an existing buildings just assessing the performance, just double checking if the building is fit for purpose, so with no physical works. We could deal with existing buildings, making modifications, going on with interventions, or dealing with change of use for buildings, and basically dealing with all the important things related to this. How we have tried to approach this huge topic in the book. First of all, we have tried to provide a bit of jargon about important information on existing buildings, and also code and recommendation framework. What you can see in this slide is, for example, the hierarchy of terms for existing buildings provided in the ISO 13822, and the different level of approaches and terms that you will be using when dealing with existing buildings. The other piece of work that we have been trying to do when dealing with the reuse of buildings is also about what do we need to cover. So what are the important steps when we deal with existing buildings? And when we were dealing with this, we have started to cover basically the important bits about collecting, evaluating, and updating data. So what are the methodologies? What are the general recommendations for structural engineers? Also recommendation for application of the partial factor method and direct use of probabilistic methods consistent with those for new structures. So where you as engineer can find information, which code, which guideline you can use if you have to deal with the approach that you normally use for new buildings, how you adapt and adopt these for existing building. Another important piece for existing building is the very question, is the target reliability exactly the same? Do we ask exactly the same to existing structure? Do we ask exactly the same performance in all cases? Or are we happy, for example, to accept different target reliability levels, for example, when the building has lower residual working lifetime, or when the inherent value of the building is such that there is a listing aspect or conservation aspects associated to this. We have also covered the aspect of assessment based on satisfactory past performance. This is another bit that is quite important for existing buildings. Sometimes we just study the story of the building, the history of loads and so on, and we assess its performance based on the past performance. And one other important piece of information is we have a lot of information about how to deal with materials, how to deal with design properties, distribution, and so on when we have a brand new building. But what do we do and how do we deal with the problem of resistant models for the assessment? So how do we deal with the structural elements built with different materials, some of them that are not commercial anymore? How do we deal with the different detailings and approaches that are now obsolete and not up to date? What we have been trying to do in the chapter of the book related to reuse of buildings is to provide an overview, guidance, suggestion, codes, further readings, just to equip professional engineers to approach the future of structural design, advanced approaches for design, also in the context of reuse of buildings. And exactly as it has been done for the case of risk-based design, also for reuse of buildings, we have produced a case study. So there is a case study about a detailed assessment of an existing structure. In the particular case, we had a structure that was designed for gravity loads only at the beginning of the 20th century and basically could be considered a modern heritage structure. And the exercise and the case study is about, okay, how is this structure now withstanding seismic loads? So this is done in the framework of Eurocode 8 Part 3. So how do you go about dealing with the knowledge of the structure, starting from geometry? So how do you build up your survey and get the geometry and the drawings of your structure from desk study, in situ surveys? Then inspection and information about the structural detail. In that case, it was a reinforced concrete structure. So there are some situations in which you need to go for destructive and more invasive testing, some situation in which you can use non-direct testing and calibrate them. And then finally, a bit about materials. How do you deal with materials, material properties? How do you move from the average property of concrete and steel, and how do you introduce the level of confidence you have on the knowledge of the structure? The other bit of the case study has been about build the structural model, choose the right type of structural analysis, and then finally assess the performance of the structure to go through specific evaluation on what is specific intervention, if any, about the performance of the structure. Curious story about the structure. Structure was not designed for gravity loads, but since there were some wind load consideration at the time in the 20th century when it was designed, the performance was satisfactory. So this is the bit we have been doing about reuse of buildings, and I hope you will enjoy the reading. I'm now passing on to James. Thanks.
Hi, everyone. Right, let me just share my slide. Here we go. Right, so, oh, wow, thank you so much, everybody, for what you shared. I think, as you can appreciate, the future of structural design is not a simple space. It's not a simple question. It doesn't cover a simple topic. So I thought I'd just share a little bit as we talk about the future, where the idea came from. Why are we even talking about this? And this is an idea I've been personally dwelling on and thinking about for a very long time. In fact, I can kind of pinpoint where I started to think hard about this space, because it was when my co-author for Regenerative, the regenerative structural engineer, Ollie Broadbent, came to the University of Bristol when he was involved in the project Think Up, and he wanted to talk about how we embed sustainability into education. And even then I was saying, well, it's all very well talking about all of this stuff, but if you're going to propose new approaches, we need to be able to not just have the knowledge and the creativity, we need to understand the risk. We need to better understand how we quantify it and how we manage it. Now, that idea kind of sat dormant in me for a long time because I didn't really know what to do with it. And then this wonderful moment came where one of our co-authors, Scott Boot, wrote the Stone Design Guides. And I don't know if you are aware of the Stone Design Guides. They were published in the Structural Engineer a few years back. And he explicitly used kind of probability distributions and probability-based design in his Stone design. And I just kind of made me go, this is actually, you know, not only is this a thing, it's real, it's possible, we could actually be doing this. And so I then gathered together what I'd like to think is a wonderful team of experts. And you've heard from some of our experts. And what started as a very simple conversation about how do we approach design in terms of uncertainty, risk management, became a much bigger, more complicated, richer conversation as we start to say, well, hang on a minute, there's an ethical dimension here, and there's a dimension here around materials, and there's a dimension around, actually, do we even know what the uncertainty is that we're trying to model, and how do we kind of approach these design questions when we're thinking about different materials or different types of structure or different loading situations. So we pulled together a mixture of practicing engineers and academics, people who work in the risk space, work in the ethics space, work in the application of design space, and we came together and pulled all of our ideas, and we came up with a plan. And the first framing of that plan looked like this, which was to kind of frame it all around the idea of PAS 2080, and this idea that in the future, we should be thinking more and more about how we build nothing, how we use what we already have, how we build clever, how we create new materials and new approaches, and how we build efficiently. Now, this was before 2022, and the reason that's important is because in 2022, I started a journey discovering about regenerative design, which led to the publication of the book, The Regenerative Structural Engineer. And in that journey of discovery and learning about the subject and working out what exactly it was and trying to frame how our structural engineer is regenerative, which I think is super important, I came across this really helpful framing for the difference between sustainable, regenerative, and circular. Now, I don't want to dwell too deeply on the exact details of this framing, but what I realized, and I had this lovely aha moment, is actually this is a great way to frame the book. You know, we could talk about initially why we need to be thinking about this. What is the future of structural design? And what are the ethical drivers for changing the way we approach design? And then moving into when we're doing codified design, why we should design to the code and no more. How can we be as efficient as we possibly can? And how can we change our mindsets, our practices to absolutely optimize efficiency and to minimize waste? And that kind of falls in the sustainability category. But then how do we go beyond that? So if we're thinking about something like regenerative, which is maybe using something like the continuous place-based design process, which could see new materials emerge or existing materials being utilized, but from unknown sources. So for example, if we're using locally harvested timber, how do we grade it? How do we assess it? How do we understand how to design with that specific material rather than just using a more generalized material? Or if we're using a local waste, how do we understand how to quantify it and design for that waste? And what are the things that we don't know to ask? And then into reuse. So there's Flavia really nicely put it, kind of actually reuse is a big part of circular economy, whether it's reusing whole buildings or reusing parts of buildings. And that leads us into a question about what is the future of design. And in my mind, I'm excited about the future of design, the future of structural design, because to me, the engineer's role is going to change. It's going to diversify and it's going to become quite a lot more exciting. So I think this is the first time I'm publicly sharing this, so I'm quite excited about this. But I approached an artist, a guy called James McKay, who we did use some of his artwork in the Regenerative Structural Engineer to help us picture the future. And we approached James to ask him if he produced some specific work for the book, which really tries to capture visually what the future might look like. So actually I was talking to someone just this morning about regenerative design, and they were talking to me about speculative design. So maybe this book is a piece of speculative design work. What could the future look like? So within the context of designing to code and really optimizing our design and minimizing waste, what might that look like? What might it look like if we were to have a much higher degree of certainty over the decisions we made? If we were to have much better quality assurance, both on-site but also off-site in the manufacture of components, so that we could minimize risk, so that we could reduce our standard deviations and a kind of, and all of that is already built into the code if we go and look for it. And in that space as well, how do we minimize our risk around modeling, and how do we understand the complexities of modeling and give ourselves the confidence that the way we model is right? But kind of moving forward beyond codified design, because I feel like codified design is amazing, but it will only get us so far in the future of structural design, because actually if something is codified, it's also going to become more and more easy to replicate using artificial intelligence and other approaches. And so as engineers, what is the thing that we bring? And I think this idea that the future engineer will go back to actually testing materials, having a deeper understanding of materials. And the testing might be the simple, I put a Randa sample here, which is being strength tested. And it could be that, but it could be all sorts of other things. They're all sorts of rich questions we should ask. And then we quantify the behavior, not in a deterministic way, but in a probabilistic way. And then we analyze it and work out how safe is it? What is the probability of failure? And to me, bringing together that sort of testing approach and that mathematical rigor of being able to model it, the probability distribution of the material, and utilize that in a reliability analysis feels really, really, really exciting. And that could look like different things. So here, it could be in the reuse of buildings, and we might be thinking about different materials. We might be testing different materials. Again, we might be recertifying materials ready for reuse in the future. We might be thinking about how do we investigate and test existing buildings, as Flavia talked about, and how do we use probabilistic approaches? So how do we use things like Bayesian updating to take what we already know and then add additional information from our own kind of testing as we develop further our designs? And I'm excited about what is the future of design. How can we really move forward, and how can we make really informed decisions using risk-based design approaches? And this to me is probably the most exciting slide, because what it captures is, and I'm not sure how well you can see it, but the case study that Raffaele presented earlier, which is essentially a speculative case study, it's what it could look like, includes some analysis of what is the CO2 related to the original construction, but then what is the additional CO2 required to repair or restore the building if it's damaged due to exceeding serviceability limits or ultimate limits. And what we find is that there is actually an optimum solution which is optimized for minimizing carbon, and we can actually do as we start to emerge these approaches, we can start to actually think about what these calculations could look like. And to me, this is really exciting because it brings my passion for kind of making a genuine change in the way we design, together with my desire as an engineer to design things that are safe and to design things in a way which is rigorous. And so, it's not well, we just throw caution to the wind and do whatever we like, but it's actually trying to come up with a rigorous approach to really designing for the future. And so I'm quite excited about the future of structural engineering and what we might end up doing. I'd like to think that we will do less sort of mechanistic design, and we'll do much more playful design using a combination of testing and maths. So if you'd like to know more, we would love for you to find out more by picking up The Future of Structural Design, which is really, in my mind, at least a companion piece to The Regenerative Structural Engineer. These are two thought leadership books. The book is coming out in March 2025. Now, I can't give you an exact date for when it comes out. What I can do is give you a log normal distribution of when it's coming out with a mode of the 3rd of March. So I hope that you are enjoying that as much as I enjoy pulling that together. If you're not yet sure what I'm talking about, read the book, find out all about log normal distributions and why they're helpful for certain situations. And thank you very much for listening and for watching. I'm going to stop sharing, and I'm going to now invite my co-presenters to join us. Join me, I should say. Thank you so much. And I'm hoping that, yes, come on, lots of questions. Excellent. So whilst we're waiting for Flavia and Alex to join us, again, I would just quickly start scanning the questions, and I'd encourage you to put in as many questions as you can. The more, the better. We've got about 15 minutes for questions, although we can go over slightly, but not too much. So Alex and Raffaele, we're just waiting for you to re-emerge. I'm hoping you're just about to click the button. Alex and Flavia, sorry, Raffaele, I can see you're there. Raffaele, whilst we're waiting, let me see if I can find a good question for you. Wow, we've gone deep. We've gone deep with some of these questions. Okay, let's start here. Do you think, so this is from Alexander Kennedy, do you think the idea of engineering judgment will be all the more important in the future? Will we never know everything about the existing building, but we can do enough work to feel comfortable enough to satisfy our engineering judgment? This will also be hard to sell to clients. Do you think this will mean engineers will take more risks to win projects? So there's lots of questions in there. So Raffaele, let's start with, do you think the idea of engineering judgment will be all the more important in the future? I don't know if you have a view.
I will try to reply to this question. So engineering judgment is definitely going to be more important in the future, especially as buildings are getting more complex and we are dealing with aging infrastructure, where complete information is rarely available. Also, engineers are working with incomplete data, old blueprints, uncertain material properties, hidden structural modification most of the time. So in those cases, judgment bridge the gap between what's known and what's needed to make sense, basically. So we don't want to get rid of this connection. But with respect to this very book, so we need to consider that when there are advances in technologies, for example, you mentioned AI earlier, and as we have software that can improve our modeling approach, and so we will have better and better tools to analyze scenarios. Basically, we will have all these kind of things. This will complement our judgment, the experience judgment. And in a simple word, I think that engineering judgment is about managing uncertainty in an intelligent manner. So we know that uncertainties are there. We know what we are expecting. We have methodology to deal with uncertainties. So I think, and in a definitive answer, the engineering judgment, the experience judgment is about managing uncertainty in a very intelligent way. And obviously, this experience judgment will also allow us to better communicate with clients, to be transparent, and transparency is at the base of any probabilistic approach. And in addition to that, I think that it is true that sometimes we really think that what we have, what we think is the truth, but we should also rely more on peer reviews and third-party audits. So in this kind of competitive markets that is structural engineer, I can see a lot of comments saying, yeah, clients, they want everything right now, and actually they want everything yesterday. So the risk of taking one more uncertainty to win project is real, but we know that the long-term reputational risk of a failure is also more significant. So in a sense, I think that we really think that this kind of change in implementing reliability-based approach, risk-based approach, should also consider it in contracts if possible, and in also clearly defining how risks are shared between engineers and clients and contractors. I hope I try to reply to a lot of comments that are in there.
Yeah, that was great. That was great. Thank you. Alex, I've got a question here for you from Fiona Gleed. In a world where we accept war, road deaths, and sewage and rivers, how do we prevent the socially acceptable risk for building design being set by billionaires?
No, I don't know why you think I have the answer to that question. But it's a good question. It's about, like, in a world where we don't care about the ethics of things very much, how do we get people to care about the ethics of this particular thing, and how do we keep it out of the hands of billionaires? I think it's a good question to ask in the current political climate, especially with what's going on in the US. So definitely a relevant question. But I do think that, that thing I said at the beginning about just agents or motivated agents in an unjust system is really important. You can't just throw up your hands and say, well, if there's road deaths and sewage and rivers and war, then I might as well not care about ethical things. I don't think that's the right thing to do. So playing any part that you can, of course, is important. And how do we stop billionaires? A much bigger question that is probably a longer discussion about taxation and acceptable levels of wealth distribution in society, which I would be happy to chat with you about. And in fact, is a point of discussion with students often as well.
Thank you so much. I'd like to come on to John Hambley's question. Are there lessons to learn from aerospace? I believe aircraft are subject to life extension and recertification involving mods, replacement to parts of structures. Also, their approach is, I believe, to certify based on calculation, but supported by testing. Raffaele, I don't know if you would like to comment.
Well, I think this is a great comment. However, there are critical differences in how we face structural problems between civil engineers, I would say, and aerospace engineers. So sometimes we welcome damage as a way of dissipating energy, which obviously is something that doesn't happen in aerospace engineering. But certainly the concept of recertification and material testing in order to extend the residual life of buildings is now something that it's very important. Think about the offshore wind turbine sector, where repowering it's an important where repowering means changing the let's say the critical components for either power production or the tower for prolonging the life of wind turbines. Their structural health monitoring can be an excellent way of gaining information on the health status of the infrastructure to understand if we can still use it. In terms of material testing, of course, for more conventional buildings, you can use it as a way to understand what is the current status of the building, the current health status of the building, with some approximation, of course, because again, we are able to define this probabilistically. You can calculate the risk. You can identify what are the tolerable risks, and then this certification that you are mentioning can be associated to risk. But I would also ask Flavia if she could complement this specific point.
Yeah, and thanks. Actually, there is the aspect about I think this is an approach that can be used for buildings. I have seen a lot of questions about data, people asking, there will ever be enough data to go for these sophisticated approaches. There is one very nice thing about quantifying uncertainties, that you quantify the uncertainty in the sense that you are aware of the fact that you are making a judgment based on not many data. And for example, for existing building, you start from a prior that can be general information about the average properties of cast iron based on books and so on. And then with a couple of tests, for example, you can use a Bayesian updating and reduce a bit, if you can, the uncertainty, or be aware that this Bayesian updating hasn't reduced the uncertainty. So I think it's a lot about awareness of the data available, just to address some of the questions that people have been asking about data availability. Can we move into a space where we can use these methodologies? And also to pick up on the point on clients, I think there is also a piece about communicating uncertainties. Sometimes, and
Flavia, we've lost your audio. I don't know what's happened. Sorry. Still gone. Still gone. Whilst you're thinking, Alex, I'd like to bring you in on the conversation. There was a specific question from John, and we'll come back to Flavia once the audio is back on, about data sharing, which Flavia was talking to. As structural engineers, I guess there is another question around the ethical dimension of, should we keep data to ourselves to have competitive advantage, or should we be willing to share it to enable the community to update the way they design and do it better?
I would say it's hard to say like a blanket response to that.
Yeah.
But when it comes to making better choices and sustainable building, especially for countries who would benefit from having that information for free, because it might be too costly for them to figure it out themselves, I do think that there might be an obligation to share. But it would depend, on the type of data and things like that. But I think, when we're thinking about responses to climate change or just transition or biodiversity, it's a global effort. So sharing of data is part of that, sharing of technology and kind of recipes towards just transition. So that would be my answer.
Great. And I think the iStruct have been trailblazing, I think, as an institution in terms of sharing of data, encouraging engineering practices to share data with each other and enabling them to share case studies and share software that enables all practices to do an early stage designs to minimize carbon. So I think there is now a precedent for us as a community working together for the greater good, which I'm excited about. Flavia, sorry, you got cut off because of your audio. You're back.
Am I back? Can you hear me?
Yeah, you are. Yeah, we can.
Fantastic. Yes, I was just mentioning about the point about data availability and the fact that some of the tools that we have in the book, that we have covered in the book, allow people to put the right confidence in the amount of data available, regardless how many they are. That I think it's very powerful. And there is also a piece about communicating uncertainty to clients, and possibly with the savings associated to this, that I think could be very powerful to change some of the things, to change some of the practices in the industry.
Yeah, thank you for that. Just aware of time, we have just passed 7 o'clock. So I'm going to ask one more question, which is, has anyone considered using structural health monitoring to quantify uncertainty? Flavia, I don't know if you would like to start.
I think it can be an option, but there is indeed the question of confidence. So it's indeed an option that the structural alert monitoring can tell you, for example, how the response is changing, for example, of a structure, and have an indication of damage. But there is a structure by structure aspect and an aspect related to confidence. I don't see yet the future in which we will not be inspecting any more structures, but possibly we can foresee a short-term future in which we will be very targeted in our inspections. So all these tools and tools like structural alert monitoring can help us to inspect only the bits that are generally needed, that will add more certainty or reduce our uncertainty.
Fantastic. Right. I'm going to wrap it up there with one last question, which is when and where can we get the book? Which is a great question, which the simple answer is the book, as I said, is available. In fact, I'm going to put my slide back up. Is available soon. Early March is the expected date of release, and it will be available predominantly through the iStruct themselves. The PDF will be available first, and then the physical copy, if you order a physical copy, that will be available a couple of weeks afterwards. So thank you everyone for watching. Thank you for all of your questions. I'm sorry that we didn't manage to get to all of them, but there was a really rich discussion, and I hope we've whetted your appetite for the future of structural design. The iStruct have asked me to remind you that there will be a 10% off voucher, which you'll get emailed to you apparently. So if you'd like to use that, please do. And so that is the book launch. Thank you so much for watching. The recording of this will be available in the next few weeks on the iStruct website, so you can rewatch it if you would like to. And there are three upcoming events that we'd love to tell you about. Net Zero Structural Design, which is a course would highly recommend. I think you can already see quite a lot of overlap between what we've been talking about this evening and the kind of the very present conversation around net zero design. There's a lecture, FIB UK, What's Happening 2025 on the 13th of March, which should be very, very interesting. And then there's the Young Researchers Conference on the 20th of March, which is a fantastic event for young researchers. I actually attended 2 years, a long time ago. And so I can highly recommend it. And the other thing that I'd just like to bring your attention, which isn't on the slides, but does relate to net zero structural design, is I would just like to let you know that the iStructEase, How to Calculate Embodied Carbon, 3rd edition, is now available on their website. So do go and dig that out. It's free if you buy the PDF version. If you get the PDF version, it's free, and there's more thinking in there. It's been really thoroughly reviewed and updated again. And so as we continue our conversation about net zero and the impact of our design, we would strongly recommend you check that out. Thank you again for joining us on this conversation, and hopefully we can carry on the conversation in the future, and have a great rest of your evening. Thank you, everybody.